Was increasing at a rate of 4.2 feet per second, and we were given that the radius has a length of 14.5 feet, and we're asked to solve problem A, and it asks at what rate in feet per second is the area changing. So what we did was we tried to find the rate at which the area is changing with respect to t when the radius is 14.5 feet. So the equation we used was a equals pi r squared, because that relates a, what we're trying to find, to the radius, which we're given. So then we found the derivative of that, which is just dA over dt equals 2 pi r times dr over dt. And then we plugged in what we know, which is the radius, 14.5, and then dr over dt, which is 4.2, because that's how fast it's changing. And then we solve for dA over dt to get 382.646, and the final answer is 382.646 feet squared per second when r equals 14.5. So that's how fast the area is expanding when the radius is at that point. In B, what we're trying to find is how fast the circumference is changing in feet per second when the radius is at 14.5 feet. So at the instant 14.5 feet, we're trying to find how fast the circumference is expanding. So we just use the circumference formula, because that relates the two variables together, and then we just found the derivative of that, which is dc over dt equals 2 pi times dr over dt, and then dc over dt equals 2 pi, and we just plug in dr over dt, which is 4.2, and we get a final answer of 26.389 feet per second when the radius is 14.5.